Hey, hello, Algebra 1. Let me take you through a bit of QM5 Practice 2, the 1 and 2 levels. Now, in the work that we've already done so far, we've done the solving part of this, solving for the inequalities, but we also need to know how to graph these solutions. So that's the second part of that. Again, this is your 1 and 2 level. Your 3 level is taking word problems and creating and solving the equations, and then maybe graphing them. We'll see depending on the situation. Mostly when you do the word problems, it's creating them, finding a solution set, and then explaining what that means. So it's less about graphing than the 1 and 2 level. Let's do a couple of these so you know what you're looking for, and then you can move on from here and ask questions. So the first one, I'm going to take you through a couple. This first one here says 90 is less than or equal to 5 times 6 plus x. We can do some distribution. I know that's probably what a lot of you are going to do, so I'll start with that. Let's do that. 90 is less than or equal to 5. We'll just do the distribution here. So 5 times 6 is 30 plus 5x. We're going to subtract 30 from both sides of the inequality, and I have 60 is less than or equal to 5x. And knowing what I know about inverse operations, I'm going to divide both sides by 5. And I have 12 is less than or equal to x. Now, in order to make graphing more efficient, you're going to want to have the variable on the left-hand side. Let's rewrite this. I'm going to still have the x, and I'm still going to have 12. Now down here, we had, the alligator, the inequality symbol opening towards the x. That still needs to take place. We still need to have it opening towards the x. We switched it around. 12 is less than or equal to x, which is what's down here, is the same as x is greater than or equal to 12. And so here's how this works. Here's how this part works. All right, if you have a less than or greater than symbol, we're going to use an open point. What that means is you can go really, really, really close to that value, but not exactly equal that. In contrast, if you have less than or equal to or greater than or equal to, we're going to use a closed point, which means that it could exactly equal that value, right? What does that look like here? So at 12, I'm going to put a closed point at 12 because it's greater than or equal to. And then I need to think about this. Values that are greater than 12 are values like 13, 14, 15, 16, 17. Those values are out to the right. This is the solution set here. So you'll notice that I drew an arrow to the right from this one. Check values. I like to use 0. All right. Is 0, let's check 0. Is 0 greater than or equal to 12? No, it's not. So I would not draw an arrow towards 0. Now 0 is somewhere over here, but I would not draw an arrow that direction. Okay. I would draw it the opposite way. Now, let's look at another example here. I have 24 is greater than 2 times v plus 7. Now I know whatever value that I get is going to have an open circle because it's just greater than. It's just greater than, not greater than or equal to. That means whatever value we end up with can get super, 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 super close to that number, but will never equal that number. Okay, so let's take a look. I'm going to do something a little bit different this time with number 3. I've got 24 is greater than 2 times v plus 7. Now with this, I'm going to treat this as an interesting two-step equation. I could distribute through. I could make this 2v plus 14. Another way to do this, you could actually start out by dividing both sides by 2. Is it more efficient? That's up to you. In this case, I know I'm not going to end up with fractions, which are sometimes can be more, I don't want to say tougher to work with, but sometimes you got to have a little, you got to put more brain power into it. And when you're just trying to, to work through and get these facts down, let's do the best job, the most efficient job that we can. So if I divide both sides by 2, I have 12 is greater than v plus 7. And that's because 2 divided by 2 simplifies to 1. So I have 1 times v plus 7, or just v plus 7. And now, all that I have left to do is to subtract 7 from both sides. And I have 5 is greater than v. just like we did with number 1, we're gonna want to write the variable first. I've got v and I've got 5. Now this was opening towards the 5, so it still needs to open towards the 5. That's a v, by the way. I know it looks a little bit like an r, so v is less than 5. I'm going to come to 5, and because it's just less than, it could never equal 5, I'm going to put an open circle at 5. Now I need to decide which way I need to draw the arrow. Well, less than 5. V is less than 5. Pick a value and check it. What's a nice easy value to pick, Mr. Raymond? 0. It's a great question. 0. Check 0. Unless it's equal to 0, then you got to pick another one. But let's check 0. Is 0 less than 5? Yeah, 0 is less than 5. So my arrow that I draw is going to be towards 0. It's going to go past 0 and it's going to continue on forever to a negative infinity in this case. Okay, this is what you're looking to do. Now, one thing that you got to remember is in number 4. Number 4 has an interesting little tidbit here going on, right? If we have division by a negative number, so I'm going to start this problem. I've got 10 is greater than or equal to negative 2 times n minus 4. I'm going to do the same way. Now, you know what? I'll do distribution. Why not? 10 is greater than or equal to negative 2n plus 8. I distribute the negative 2 times n, negative 2 times negative 4. Well, if I'm solving for n, I'm going to subtract 8 from both sides of the inequality. I have 2 is greater than or equal to negative 2n. And to solve for n, I need to divide both sides by negative 2. Now, this is negative 1, and this is n. But when you divide by a negative number in an inequality, you must flip that inequality. So in here, it's less than or equal to. This now becomes, hold on. This is greater than or equal to, becomes less than or equal to. Notice how this flips. Flip. Because we divided by a negative number. And again, we still like to write our variable first and our value second. Still needs to open towards n, greater than or equal to negative 1. We'll put the closed point because it could equal negative 1. And let's check 0. Is 0 greater than or equal to negative 1? Sure is. It's going to go this direction. We'll pretend like that's a nice line that I've drawn in here. Okay, your job is to finish the next 7 and ask any questions that you might have. Take care. Have a great day.